improved method for measuring the rate of product being formed is to find the change in mass. From the conservation of mass, we know that mass must actually be conserved during a reaction. So what we're measuring in a change of mass experiment is actually an apparent change in mass. This occurs in reactions where a gas is given off. This is because if the products are all solids or liquids, their mass can be measured using a mass balance. But a gas cannot be contained, so we'll leave any container, meaning that its mass will not be measured and the mass will appear to decrease during the experiment. In this sort of measurement, we therefore make an estimate of the speed of the reaction using the mass balance, which allows us to measure the mass of the reaction flask during the experiment. In order to carry out this sort of experiment, the reaction flask is sealed and placed onto the balance. At this point, there will be an initial reading on the balance, which accounts for the mass of the reactant and the flask. As the reaction happens and gas is released, the mass reading will drop on the mass balance, indicating the mass that is lost due to the gaseous product. Placing the reaction flask onto the mass balance allows measurements to be taken at regular time intervals. As a result, a graph can be plotted of the mass of the gas product against time, where the mass of the product that is a gas is just calculated by the difference between the initial reading and the reading at that time. An example of the sort of graph that you can plot is shown here, with time along the x-axis in seconds, indicating the time since the start of the reaction, and the mass of gas product produced on the y-axis. At the beginning of this graph, the graph is upwards sloping as the amount of product formed increases during the reaction. For example, at this early point, you can see that less gas product has been formed than at 4 seconds. The graph also shows a region in which it levels off, which can be seen here. This happens when all the reactants have been used up, and meaning that no more product can form and the reaction stops. At the beginning of the video, we defined the rate of reaction as a measure of change of concentration of the products or reactants per unit time. When calculating a rate using this method, the units for rate will be the units of mass divided by the units of time, as it's the units of mass which is changing and it's what we're measuring. In general, the units for rate will depend on the units used to measure the amount of product or reactant. So in this case, our units for rate is equal to the units of mass, which is grams, divided by the units of time, which is seconds. So here, the rate is measured in grams per second. You might also see grams per second written as
Hi guys! To continue watching this video and unlock hundreds of other super concise and exam board specific GCSE chemistry and combined science videos, just click on the Snap Revise smiley face. Join me today and together let's make chemistry at GCSE a walk in the park.